One of the major uses of the three-line charts is that it allows us to answer questions about one level, so for example f of x typically, if we know something about a different level, often f prime, sometimes f double prime. So what we're going to be looking at in this lesson are problems like this, where we're told something about the function f of x. It has a derivative f prime of x, and that derivative f prime of x is graphed below. And then we want to find information like where or what values of x f of x has a relative minimum or a relative maximum or an inflection point or whatever. So these are the steps that we're going to go through. We're going to be using this table and our three-line charts again. Basically what we're going to do is we're going to sketch the three-line chart for what we're given. So in this case we're going to be given f prime of x. We're going to translate that to what we're asked about, which is f of x, answer the question, and then justify it. So if you take a second, pause the video, and sketch this little diagram here for this problem. We've got f prime of x, we know that right here, so I'm going to go ahead and do my three-line chart for f prime of x. And I told you right up here where the inflection points are for concave up and concave down. I'll just put in the other ones. Okay, so there's an inflection point at -1, 1, and 3, so concave down, concave up, concave down, concave up. Increasing, decreasing, so stops increasing at -2, then it's decreasing until 0, increasing until 2, and then decreasing again, and then there are zeros at -3, -1, and 2, so plus, minus, and minus. Okay, the key thing that people mess up here is that we're asked for a relative maximum, but we're not asked for the relative maximum of f prime of x. We're asked for the relative maximum of f of x. So we have to translate this, and most people, if they're going to make a mistake, they forget to translate. So this is f of x, and remember the correspondence up here. So if we know a bunch of stuff about f prime, we only actually know two levels of f of x. So increasing, decreasing in f prime translates to concave up, concave down in f, and plus minus in f prime translates to increasing, decreasing. So that being the case, we can label this increasing to concave up, decreasing to concave down. Positive to increasing, negative to decreasing. Okay, now we can answer the question. F of x has a relative maximum. So relative maximum means a change from increasing to decreasing. Right here at -1. And this is the justification part. We need to include stuff from the original information, f prime of x, and also what that means for f of x. So at -1, the reason that we have f of x changing from increasing to decreasing is because f prime of x changes from positive to negative. And voila, there's our answer. Once we have these three-line charts, we can answer a variety of questions about f of x. So let's just say part B, where does f of x have an inflection point? And we're really just doing the same thing that we were doing. We're saying, okay, we've translated from f prime of x to f of x. Where is there an inflection point for f of x? And we see that right here at -2, 0, and 2. And how do we know that? We know that because f prime of x is changing from increasing to decreasing, or vice versa, and that means f of x changes concavity. And so on and so forth. Once we have this chart, anything on there is fair game. So, for example, we could say, where is f of x decreasing? I'll write here from -1 to, let's see, that was 4. Notice that there is this point here where there is a 0 for f prime of x. So it's sort of a questionable thing of whether or not that 2, whether or not when x equals 2, f of x really counts as decreasing or not. There's debate in the mathematical world about this. The AP test will accept either way. And just to give you some practice with the vocabulary, let's look at one other one. Where does f of x have a local minimum? Now remember, local minimum is the same thing as relative minimum. So what we're looking for is we're looking for where f of x changes from decreasing to increasing. Notice that that actually never happens. So in this case, f of x doesn't have a local minimum because f prime of x never changes from negative to positive. So f of x never changes from decreasing to increasing. And there we go.